Welcome to episode 338 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm okay, Rob. How are you doing?
Doing good. It's 2/22/22.
Oh, yeah.
Special
it's
date.
2.
Yeah, a lot of twos.
Although I always write the year in 2 digits just because I always, everything now, I just use ISO date format. So like if I was signing a document today, I would actually write 2022/02/22, which I know no other human does, but it works for us in America because the month and the year are in the correct places. So no one in the States complains about it.
Right.
And I get to feel better about myself. So yeah.
Nice. It's good. It's good to have standards. Yeah. Okay. Well, at the top of every episode, I like to read a piece of feedback. I was looking through our YouTube comments, and we got these ones in regards to our recent episode with Brian Kernahan, saying Brian sounds like a really likable person on a human level, and another comment just saying legend. It certainly was great talking to Brian on the show a few weeks ago.
I saw a bunch of Twitter comments that were like, "Oh, he's a treasure. That was a pleasure to listen to." Like all kinds of things like that.
It was fantastic to talk to. It was great. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Khalil Estell. Khalil is a software engineer at Google's Wear OS, currently working on bootloaders, audio, and haptics. He spends his free time as a volunteer staff member at San Jose University College of Engineering. He's mentor and sponsor president of the robotics team at San Jose State University. And Khalil is also a creator and maintainer of the lib-embedded HAL open source projects. Khalil, welcome to the show.
Hello, nice to be here.
Yep. What is Wear OS actually like? Is that the Watch OS?
Yeah, the smartwatches, yeah.
Okay.
Yeah, so like if you get like the latest Galaxy Watch 4, like that's using our operating system.
Okay. And is it directly related to Android at all?
It is Android. It is Android.
Oh, it is Android. Okay.
just crunched down to fit onto a watch.
Okay. All right. Now,
does it run anything else besides the watches? The Wear OS, or is it just for the watches?
Just watches.
Okay.
You have like different kind of variants of Android that go for different things, but for the most part, yeah, when we say Wear OS, we're just talking about the smartwatches.
Okay.
I feel like we risk, going into the interview portion here, but now I'm totally curious. Like, what are the capabilities of a watch that Wear OS has to run on compared to like a modern Android phone might have 6 gigs of RAM, right? Like, I mean, it can be ridiculous. What's a watch like?
Yeah, crazy thing is that they're not like, so this is a gigantic spreadsheet with like all the different types of watches and what their like capabilities are. For like the low end watches, you could see, depending on which version of Android you're using, maybe like half a gig to a whole gig.
Okay.
And then you can get some that like have like multiple gigabytes in there. So like, yeah, no, it gets kind of crazy. But for the low end, you can see like, pretty reasonable SoCs being used for it. I don't remember like any of their speeds or like a lot of their characteristics. But yeah, when it comes down to like at least RAM and some storage, usually a good amount of, not kind of comparable to actual watches, to actual phones.
Right. I feel like, it was a day not that long ago. Well, not that long ago to me, but now I just feel old. Like 20 some odd years ago, that you would just assume embedded development meant like 128 bytes of RAM on a device clocked at 1 kilohertz or something. And now you're like, oh, well, embedded, I actually have a full Linux operating system with 5 gigs of RAM. It just happens to be running on a watch.
Yeah, it's actually kind of amazing because like you're like, that all fits on there. Like we were able to get into that form factor. Like,
that's crazy.
Yeah, it's really impressive. All right. Well, Khalil, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about the work you're doing in embedded development. Okay. Awesome. So this first one is the Keynote from CPPP is now available on YouTube, and this is Matt Godbolt on C++'s Superpower. I unfortunately made it halfway through the talk before we had to get on, But it was a really good talk so far. And he's talking about what he thinks as C++ superpower as being able to look at really old C++ code and kind of bring it up to speed incrementally.
Yeah, Matt had given this talk at my meetup. So yes, I have a meetup. It's mostly remote these days, just that I would say that out loud again. But as a preview a while ago, but I had actually forgotten what he talked about. So I was rewatching it also just before this. It is a good talk.
You know, I actually love that talk. I know like Jason's done quite a few videos like converting C to C++. I remember seeing a portion of the Doom transition.
You didn't stick around for the 15-hour live stream?
Yeah, no, like I saw a bit, I was like, this is awesome, I'll watch it later. And then I remember looking at it again, it's like, that's a long stream. I was like, I'll think about it. And then I just got other things. Yeah, no, like I love the cat also making an appearance on the presentation. But like, I think I actually liked his style of showing the transition between old code and new code. I think it was actually quite entertaining, kept me the entire time. It made me also realize that maybe I should like learn a bit more about ranges. I don't use them very much. I don't think there's a lot of... I've had too many cases yet where I needed them embedded, but I think they may come up useful later on. And then I didn't know about zombies, like the term zombies for unit testing. I feel like I've done a lot of that stuff before, but I just never had like an acronym to go with it. So it's happy to know, and if any of the viewers aren't sure what zombies is, it's like 0, 1, mini, boundaries, interface definition, which I actually don't know what that means. I still need to look that up. Exceptions and simple use cases. So I thought that was really cool. And there's one other bit that I really wanted to talk about that like he talked about, which was like the compiler error driven design. Which that was cool, and we all do that. We all let the compiler tell us what we've done wrong. But I go one step further, and this is from my time when I worked at Google Assistant. I use, and I've taken this everywhere else too, I use CIDD, continuous integration driven design. So let's say I have a whole bunch of features, and testing them takes half an hour to an hour, or something extreme like that, where you're having to build a good 250,000 or 500,000 files. Rather than write your change, test your code on your machine, I will just throw it off to the server, have the server run all its continuous integration steps, move to my other branch, make my changes there, shoot that off, and keep round robining until eventually I get back to my original one, and then check the CI to see if it's there. And if I have more time to spare and everything's still running, I'll go get a snack. But yeah, this is something I've been doing for like years now, and like it's maybe just abusing GitHub Actions and other things like that.
Maybe a little.
It works out really well. Yeah.
Do you then, out of curiosity, when you're doing something like that, do you end up doing like a squash merge after that because you had a bunch of like tiny commits that were just basically poking the CI? Yeah.
So in this particular case, when I was like, I do this on my open source projects as well as like when I was an assistant. I was a Google Assistant. A lot of the features I try to keep separated. If they were the same feature, I'd probably just squash commit them and then send them off, because that's a big thing at Google, is like having a single feature in one single commit, not multiple commits. I usually just do an amend commit. Usually they're separate. I try to do this only on separate commits. If they're the same thing, then I test them all in one go.
Okay, very cool. Next thing we have is a post on the Visual Studio developer blog, and this is that Visual Studio 2022 17.1 is now available. And this is covering all the changes in the new version of Visual Studio. There are a couple highlights, I think, in here for C++. Enhancements for embedded in RTOS make it easier to be productive. So that's being able to look at embedded registers, which I've never gotten and looked at, but seems like something that might be helpful for someone like you, Khalil.
Yeah, to this end. So I saw that little blurb. I was like, oh, that's really neat. That's really cool. And I know like most debuggers usually won't kind of present that unless you put it into some aspect of either as part of like a local variable, or part of like your memory map of some sort. Although I kind of just use like, so I'm maybe I'm weird. I don't actually use Visual Studio almost at all. I use just normal VS Code, GDB from command line. I use this thing called Gdb Dashboard. If you or someone uses GDB on the command line, I highly recommend looking up that Git.
So do you use VS Code with GDB but with CL?
I use Visual Studio Code just for writing all my code, and then I do not use the I do not use VS Code's debug system.
Okay.
I had used it before. Honestly, so the reason why I don't use it a lot is because back in the day I didn't have it, so I used GDB a lot, got used to that. When I
Right.
finally got it, I was able to use it, but now I'm on this Mac, and this Mac has problems with running GDB. I have like the latest MacBook, so right now I'm just going back to my old roots. But one thing I used to do... So what?
Sorry, I said LLDB then.
Yes, yeah. So I have been learning LLDB because I've actually never used it until I moved over to the Mac. The only thing I was going to say on this is that normally I would just turn on the mim and accessible from GDB so I can access random pointers and just do print name of the register, and then it'll pop out all the information. So it's similar to how Visual Studio does it.
Very cool.
I have just a completely tangential question here. When we're talking about Visual Studio, and I mean this for everyone, Visual Studio 2022 17.1, that doesn't even reference the compiler version, right? So we've got the name Visual Studio 2022, and then its actual version number, and then I think the compiler version is technically its own version number. How do we reason about Visual Studio? Should we just call it 17.1? Is that acceptable? Do we need to say 2022 each time?
I mean, I think of it as Visual Studio 2022. I forget what that, the 17, I forget what that version number is.
That definitely, because Visual Studio 2019 was Visual Studio 16.
Right.
It's like a marketing name versus a version number.
Right. I think of, the marketing name, I guess, is what I remember. But yeah, what version the compiler is, that is different from each of these as well. And I can't remember what the compiler version is right now. Yeah.
Sorry.
Okay. Next thing we have is a blog post on making a cross-platform mobile and desktop app with Qt 6.2. And I think we talked about Qt 6 coming out a while ago. A lot of big changes from Qt 5 to Qt 6. And this is a nice post on setting up project if you want to go fully cross-platform, both desktop and mobile. And it's a really simple application doing the OpenGL, drawing a bunch of balls and objects in 3D space. But it's pretty cool to see them porting all these different operating systems with one project.
It's a big article.
Yeah.
Definitely looks like it's a good resource if you want to get into Qt development, though.
Yeah. I will say I did not read the whole thing. I was trying to read I think a portion of it. This is gonna be a while. But I do appreciate the fact that it is possible to build one place and have it deploy in other places. That is my MO. That's actually the reason why when I first started programming, I started with Java, because that was their big thing. It's once apply works everywhere. So yeah, that's been with me since forever.
No, I'm totally curious now because did you then end up deciding that C++ is actually more portable than Java? I know people who have come to that conclusion.
Yeah. So I think at the time, that's an interesting one, because if I think about Java and trying to put it on any embedded system, that's not even. I don't entertain that idea most of the times. I would say that in a way, yeah, actually it is. I hadn't really thought about it that way. I actually stopped using Java just because a lot of the work I ended up doing fit better with C++. A lot of low-level operating systems type things. Yeah. So I'd say, yeah, I kind of came to... I didn't know that I knew that, but that's another reason why I use more C++ than Java, is because it fits in so many different locations. And for what I'm developing, this is exactly what it's meant for.
Okay. Well, that fits with our target audience here. So I mean, there was a day that when Sun first released Java, they advertised it as being able to run anywhere. There was one of the first Java World conferences or whatever. They had the Java Ring that was running a little JVM on it that they gave out to attendees or something. They made a big deal about this, but then it seems like that notion dropped off pretty quickly.
Yeah.
So I had one more thing that I put in the show notes right before we went on. So I don't know if either of you had a chance to look at this, but one of my coworkers sent me this. It's a VS Code map preview. And if you were really interested in our discussion last week where we were talking about GDAL, if you're into geospatial development, this is a handy looking VS Code extension where you can open up different formats like GeoJSON, which I think is one of the formats we talked about last week with Matt Butler. Open it in VS Code and be able to visualize it on a map. Just seems like it's a really neat and easy to use way for previewing some content that's geospatial.
And I think anyone who's done like trail mapping would be familiar with GPX as well.
Yeah, GPX, KML is another format it supports, which is what Google Earth exports. It's another really common one. All right. So Khalil, let's start talking about how you got into embedded development. Now that you mentioned that you work currently on Wear OS.
Yeah. So kind of rolling it back to my starting. So I actually got started with programming at around about 13. My uncle Alonzo got me started on this. And right when I hit around senior year of high school, I was writing some programs and something just kind of hit me. I was like, how does any of this work? Like I do system.out.println or I do printf, and I'm like, things come out on my console, but how does that even work? And how does my terminal work? And I started like really digging deep into realizing that I don't understand anything about this computer that's in front of me. I can tell it to do things, but that's pretty much it. So I went on to OS Dev and started like looking at how to make my own operating system so I can learn it from scratch. And I made some progress, made like a small little operating system that you can run on QEMU, which was really neat. And a little bit of a side story that goes into this as well is I was applying for colleges. I put in computer science. I go to get some food for my mom, and she's like, "What school did you apply for?" I was like, "What college did you apply for?" At computer science to college. She's like, "You should go for computer engineering because your grandfather was an engineer. You should go for engineering. Like you should be an engineer. Don't be that scientist type thing. No, I'm a scientist. I'm a biology major. No, you should go for computer engineering." So I was like, "Okay, all right, fine." So I go back. I switch it. I didn't look it up at all. I just I'll switch it over. I go into the San Jose State's Spartan Day, kind of like their open house, and see the major, and they're like, we do embedded systems. They showed us all the projects and all things you could do, and working with robots and working with all these things that got down to the metal. And when I went to one of their talks, they're like, yeah, when you come into our department, you'll learn about how to build a CPU from scratch, how to do computer system architecture and all that stuff, as well as also learning how to make the software. I was like, this is literally what I've been asking. This is the question I've been wanting to know. So that is what kind of started me off into being interested in embedded. And then later on, I started getting into robotics, and that's pretty key into embedded as well. And that kind of kept me rolling.
Fascinating. I've never stopped to think about that before. I didn't actually ever ask that question of how does this work until probably the year before I started at university, even though I'd been programming since I was 8. I just accepted it. I never stopped to say how or why.
Yeah, it was. I think just something just kind of clicked, and I was like, maybe someone asked me a question about something I didn't know, and I was like, wait, hold on, how does that work? And I realized that none of the things I've been learning thus far had given me any insight in that, and I was like, there has to be something there. And someone had to have built this. I gotta know.
So the tiny operating system you wrote, was that hand rolled x86 assembly? What were you doing?
There's a small little portion that was x86, and the rest is C.
Okay. Cool.
I didn't even think of the idea because I think all the manuals and stuff like that were all about doing an assembly in C. So I didn't even think about doing C++ with it. But now, if I was to do it again, I would totally write it in C++.
-F, no exceptions.
Yep.
There are definitely limits if you want to write boot code in C++.
Yep.
So you went to school, you went for the computer engineering major, and you now spend some time as a volunteer staff member at the university. Is that right?
Yeah.
So tell us more about that. You do some teaching of embedded development to other students? Very cool.
So there's a course, Computer Engineering 146. Its name is real-time, actually this name is kind of confusing. It's real-time coprocessor design or something like that. It's basically the embedded class where we teach concepts like GPIO, what pins are, voltage levels, SPI, serial communication protocols, free RTOS, and specifically use free RTOS because it's free. And honestly, every place I've worked at usually uses free RTOS anyway. Along with teaching that class, and I also kind of help out with some of the other coursework as well. I helped out with doing or updating classwork for the courses that go into FPGA development. I've helped out with classes that have to do with computer architecture design. I really love that class where you say, here's a CPU and here's some peripherals, wire them up so that they all work, and do memory mapped I/O and stuff like that. Do it in simulation and prove it out in like an FPGA or something on those lines. It's really cool, and you get to really feel like you know everything from the bottom all the way up. So I did a lot of help with. I've done a lot of work with that kind of class, and like some other little things with working with some students and summer projects, stuff like that. And that's kind of like the majority of what I do for the class. Oh, I will say though, one thing that I love to talk about is just for that. For the end of the class, you have 6 weeks, and you have 6 weeks. I usually give 6 weeks to do the final project, not because it takes 6 weeks, just because like I want students to be able to like live their lives and do other things for college. Because yeah, and you build an MP3 player, and the cool thing is that in your class, every single lab, you build another driver. And I tell you, whatever driver you build here is what you're going to use for your final project. So make sure you wrote it right. Make sure you followed the guidelines that I have here. Make sure you follow the right guidelines, because if you don't, it'll cause issues. You're able to edit them later on, but you have to edit from where you were. And if you make a dramatic change, you have to talk to me so I'm making sure you're not cheating along those lines. It really, like that whole combination, like that setup makes students so much more interested in making sure they get the lab work done and that they understand how everything works, so that when they get to the final project, they can blow it out of the water. And I've always been super impressed with what my students have come up with.
It's really cool.
That's just an awesome idea. Do you ever have the situation where someone gets to the end and they're like, well, you know, I was never ever able to actually complete X driver, therefore my project just doesn't work, and like how do you address that?
So there's 2 ways. So we usually take 2. So each team has like a part. You have one person, you have a partner.
Okay.
We have these people combine. So it kind of helps blend that together. But if they're in a situation in which both teams did not work on that same driver, I will tell them like you're going to want to develop that driver yourself. And the later ones are the harder ones. So hopefully you develop those ones when you have the time to, and not later on. So it's another thing where I have like some leeway for people who can't make it to certain things, can't get the lab done at the right time for, you know, other reasons outside of school. But usually students are able to. I've had a couple students who couldn't get a certain driver done, and they implemented it in line with the project and got it used it in the actual project.
Okay. So now I'm curious too, when you say they make an MP3 player, like what is the end result of this? Like how much of the hardware, software did they actually like assemble or whatever?
Yeah, let me take this off. So I built this board for the class. It's derived from it's called the SJ2 board. It's derived from another board called the SJ1, which another faculty member had made before.
So you actually like designed that board?
Yeah, like everything about this board is my design and taken off from. It's probably getting blurred right now.
Yeah, you got to watch on the YouTube video, everyone here. Okay, so what is that, like 2 inches square-ish, like 4 square inches total, maybe?
Yeah, around about 2 inches square. Okay. Sorry about that. I forgot we have people who are listening in. So it's a board. It uses it's a development board, has like a couple of buttons, LEDs, I/O expansion, Wi-Fi port, screen, a lot of other sensors on there as well. And the students are kind of given this to develop on.
Okay. And
they are allowed to. There's a particular MP3 player module that you have to talk over SPI to. You have to use one of your drivers that you built to talk over to it.
So it's a hardware module.
Yes, a hardware module. Okay. So you're kind of dictated if you do this particular project to use that hardware module. And the only things you're really given is I give you a SD card driver that I wrote, a fat file system driver that El Chan made, and I think that's pretty much it. Everything else you have either written already. Oh, and the boot up code is the code that I give you. Okay. But everything else is drivers that you developed yourself, and you just apply those for the project.
And this is
the end result is they're going to plug in an SD card with some MP3s
Yes.
and connect a speaker to it and actually listen to it. That's really cool.
100%, yes.
And that's
some students made
RTOS on there. Sorry.
Yes, and there's like some rules on like how you have to do multi-threading in order to get the performance just right and stuff like that.
Okay. And they're doing this in C++?
C++.
Nice.
Yeah.
Was there a display on there so they could see like what track was being played or something?
Yeah. So there is a display on the board, and then for them, they can also choose their own display. I've had a lot of students who decided there's this other really cool display where like all you have to do is put in an SD card, it does all the reading, and like you could say like you know, you send it some command that tells it to print this image in this location, it'll do it for you. And I'm like, that's fine. Like, I'm cool if you can find some devices that do some really cool graphic stuff. Sure. I've seen some people do some really crazy graphics work for the MP3 player, and I love it.
Has anyone done anything like, because I know I've seen like Arduino projects that do this, like directly drive a VGA display or something like.
There hasn't been any direct displays, VGA displays. I think I know one person, a coworker of mine, who also was from SJSU, who would have very much done that if he was able to go back in time and take it after I started teaching it. But no, nothing like that yet. That would have been super dope. I did write a VGA controller for students to use for their FPGAs, so they can do it for that. But like for this project, no one's done that.
That's a lot of high-speed I/O port pin twiddling there. Yeah. That'd be awesome, though. Look, I got it working. It's only 8 pixels because that's how fast I was able to drive the I/O pins, but it works. And then really, that's all that matters sometimes, like.
So when you're teaching these classes, and you said you are, they are programming in C++, are there any like specific techniques that you kind of wanted to share with, how you teach them C++ for embedded development?
Yeah. So I've been teaching in like the last couple of years. COVID kind of started up, and then we had another couple faculty members who were taking over the class. And as a volunteer staff member, they kind of have more priority since they were, paid individuals. And I really wish I could have gone over solid principles. I did go over polymorphism. I did go over I had to keep in mind that like some students were very afraid of C++ because we do use it in 1 or 2 classes, but after that a lot of classes don't really need it. So I try to give them a nice introduction to encapsulation, making sure they understand why, how to design an API and what makes sense to put in the API and what makes sense not to put in the API. So it's kind of like the rudimentary basics of software design, and then making sure that they aren't doing something silly. Like for example, I had some students who would cache the value of a pin. And then I'd ask them, well, why would you cache it? Because you almost should always ask the actual peripheral what its state is. Because if you cache it, what are you gonna return? This cached version or the actual version? And these are things that some people don't even think about. They think, oh, I'm just gonna cache it and that'll make it easier for me to use for later. But then they read it once and then they never read it again, or they never read again. So things like that. For my students, it's really just kind of getting the idea of encapsulation and also explaining to them why using C++ and embedded is not gonna blow up their file size. A lot of people assume that, but there are things you can do to make sure it doesn't do that. Quote, don't use IO streams ever.
Yeah, don't even include IO stream, or you've got some static globals that are instantiated.
It's 150 kilobytes added to your memory.
Just including it?
Just including it, yeah.
Okay.
Yeah.
That's special. Do you, that actually raises an interesting question to me, because then something like lib format for actually formatting strings that you want to display on your tiny embedded display could be useful. Does that get used?
Yeah. Well, so I haven't seen anyone else use it because it's still really new and people are kind of not sure. Most people are going to be doing printf stuff. Right. I've actually worked with I added a couple of defines into lib format or format lib just to optimize it a little bit further. So if you turn on all the flags and also remove floating point support, you can very well get the size down to 12 kilobytes.
Okay.
But if you're going to use printf, it'll go down to I think 4 kilobytes if you have no float support. If you add in float support, it goes up to 19 kilobytes. So it's a pick and choose on what you really want to do.
Okay.
But you can very well get format lib onto your embedded system. You can totally use it. I've done it before.
And since we were all just talking about Matt's talk at the beginning of this, and he talks about some of the issues of using sprintf and overflowing your buffer, does that kind of conversation come up when you're teaching these students?
Oh, absolutely, 100%. These are kind of things that that I will. So the idea of how to design your stuff. For example, he had that one buffer that was static to a particular function, and if anyone else goes to try to capitalize something, that would result in a whole bunch of shenanigans if you have anything multi-threaded. Right. So I talk about here's certain resources that you need to check, and I ask them does it make sense to have a mutex to block using the capitalize function, or should you maybe come up with a different way to implement this. Maybe just pass it as an out parameter. It depends on what we're doing. A lot of times we don't use the STL or things that allocate in embedded, so I tell them like you should shy away from that. You could use string. It will fit. It'll work for your class, but like normally, if I was telling you if you want to make it efficient, you could just pass this out parameter. There's some other options that they have available to them, but yeah, like that is the kind of stuff that I would talk to them about, so that they don't make the type of mistakes when they work on the project, also when they go out into the field.
So you mentioned multi-threaded and RTOS, but are these actually multi-core processors that are being used? Okay.
No, I think the main thing is that like usually that probably capitalizing whatever string you're capitalizing would never like, hit the boundary. But if you just started it right before the system timer hits and then basically swaps you to somewhere else, then now you have problems.
Oh yeah, you still have a race condition. Yeah. So then you for the sake, I'm just thinking back to this MP3 player project, and you said they need multi-threading in some cases to get the performance. Is that in that case just mostly about like task switching, like while you're waiting on I/O, go do this other thing? Okay.
Very much so, yeah.
Cool.
So is this class with the MP3 player, is this part of computer engineering or computer science course?
Computer engineering specifically.
Okay.
I think I learned like a month ago that they may have, because of COVID and the chip crisis, because you can't make more of these boards.
No.
Yeah, like I think they might have demoted it to being like an elective versus it was actually part of the core of what you learned in as a computer engineer from San Jose State. But yeah, so it is part of the computer engineering department.
See, now that's really unfortunate because, there was some contingent of our listeners that were just thinking, how can I order Khalil's board? And you were getting ready to start your own, side business here. And now that's just not possible.
Yeah. Unfortunate. Yeah, the LPC chip is very popular, I think, especially in the automotive space. Because of that, you just can't really find them anymore. Go on Mauser or something like that, and there's like maybe 20, and that's it. And those be gone if you refresh.
Did you use PCB ways, board populating services, or what? How do you actually build these things?
Oh, actually, for that one, I use God, I'm forgetting the name because it's been like 2 years since I've used them. Since the chip crisis didn't take very long after COVID hit. Oh my goodness. I believe I use a group called Next PCB. Don't quote me on that. I will probably put in the show notes later on. But yeah. But no, I don't actually use PCB way. I usually use JLC PCB when making prototypes.
Okay.
But when I actually want to get everything properly made and manufactured at like the scale of 250 to 500 to 1,000 boards, I think I use Next PCB or yeah.
And so it's relatively easy, and I'm not trying to get you to sell a particular brand or anything. I was just curious. You do use some sort of one-off kind of service where you can say, I want the board with these components and this design, and they'll do everything and then ship you back the completed board.
Yep, pretty much.
How much does it cost to prototype something ish?
Prototyping is expensive if you want to get everything put in. So for example, when I got a set of 5 boards, it costs with everything else and all the components, I think I paid, it might have been $400, $500. But when I buy in bulk, when I buy, let's say 200 to 50 or to 500, I remember somewhere around $4,000 to $8,000. So you can see that it doesn't scale completely. It trails off. So when you buy in bulk, that's why I usually try to use things like JLC PCB, the small ones that I could just at least solder most of the parts on, and then test things incrementally. There's some parts on here that I cannot get to because they don't have any pins available, and I don't have we have some of the things that we can do to put the stuff in, but I never know if it's is it my soldering issues or is it my design that's wrong. So
you have one of these hacked toaster ovens that I see people do on YouTube, so you can do reflow in your living room.
Oh yeah, right in my living room, with no ventilation.
Well,
yeah, I know what you mean. I know friends who've done it. I have not done it yet. Been planning on kind of doing one of those things for my own sake, but I haven't gotten it yet.
I feel like I should clarify here for the sake of our listeners. There's I believe a completely open source project that is a toaster oven hacking module that you put in temperature sensors and airflow, and add a fan and temperature sensor to your toaster oven and mount this thing on the outside of it, and then you can program what you need for reflow. So if you've got the board with the like solder mask on it, you can put the components in, put it in there, put the program and hit go, and you just took your like $30 toaster oven and made it into a solder reflow machine, and then you can prototype your boards at home. It's pretty cool.
It's really cool.
I want one, but I have literally no use for it at all. I don't even know the last time I turned on my soldering iron. I mean, I have a decently good soldering iron for minor things, but anyhow.
I guess maybe we should go back to C++ code a little bit. Do you want to tell us some more about the types of things you teach in this class?
Yeah. So. I think what you're trying to get to is like, this one of the things that's kind of different between how I design my APIs versus how other people look at it is my use of runtime polymorphism versus static polymorphism. And this has been a interesting topic that I've spoken with a lot of other people, about. And I hope you guys enjoy this part, because one thing is that I'm a big proponent of runtime polymorphism. I use virtual. I understand that you want to keep your API when you use virtual as low as the lowest number of functions that make sense for your particular project or particular class as possible, because the more items you add, the bigger your vtable is, and then you have that duplicated over every implementation inside your code. So that's one of the things I talk about in my class is when you come to your API design, if you're going to do something that is polymorphic, let's say you have a GPIO, a pin that can be high or low. You should not have a virtual class for set high and another one for set low. It should just be set or level or something along those lines, or voltage, and then you put in a bool. Usually, some people say bools aren't the best for parameters. I say if it like level is true or false, that kind of fits the semantics of what you're doing when it comes to the output of the pin.
Yeah, I'm not going to argue with you as long as it's one bool parameter. If it's four bool parameters, then
oh yeah, that's awful. Yeah, so like those are kind of things that that I kind of go over, and like I tell them about the impact of what virtual kind of has, and I say, hey, if you want this capability, I actually now would say, before I would say add a method or class function, a class function that is set high, set low, so it's like a little helper, so people just can run that versus having to put level in the value in. I would now say that it should be, if we ever get unified calling convention put in, you can just have like your own free function that takes your interface as a input parameter, and then you put your true false at the other side, and you can basically call that like as if it was a class function. That would be really neat in the future. But now I just tell the people just have them as separate functions, just because we get this feature in the future, and like it allows you to extend an interface, and also allows you to not bombard a single interface with so much detail. Because the moment you're like, oh, I want this other cool, useful thing, you're gonna think, oh, I'll just add it to the interface set of functions, and that just gets gross, and the number of includes you have is so on and so forth. So that's one part when it comes to just API design. But there's another thing when it comes down to static polymorphism that some rare students who are like really clever, like, what can you just like do it this way? And I'll say this. So my biggest reason for runtime polymorphism over static, and this might sound oxymoronic, is for size. You may think like, wait, hold on, shouldn't static be like, smaller usually? Well, you kind of run into some issues. A lot of times nowadays, since we have concepts now, you could go, oh, I have a concept of a pin, and here are the different set of functions. Anytime you use a concept inside of its parameter, inside of function parameter, it turns that entire function into a template. Not too bad, that's fine. Now let's say you've called one of the functions with one particular implementation, another function with another implementation. Assuming optimizations are turned off, you'll have two different instances of that particular function. If you have n number of them, you have n number of instances. And if you have multiple other functions that will take that parameter, you'll get n times n for the number of functions you have and the number of types you're trying to put through them. So that starts to grow. Whereas if you were using runtime polymorphism, you wouldn't have to worry about that size increase. All the call conventions are exactly the same. And I think one other thing to add in is that in general, when it comes to embedded systems, you're usually compiling with OG for debug, but reduced size. O2 for reduced size and also higher performance, OS for smaller size, and you almost never see O3 used unless you're okay with, you need more performance and you're okay with increasing the binary size, because it'll almost always be greater than O2. and OS, much greater than OS. So keeping the size down is really important for a lot of projects, because won't always have like a half megabyte or a megabyte or 32 megabytes of flash space. You may have 64, in some cases 32, even worse cases 16. Like it can get pretty small. And here's the monster I kind of want to paint for this, because it gets a little complicated, but I think it's important to bring up, which is what happens when you start to scale and when you have multiple implementations of the same concepts or same types. Let's imagine that we have some 4-layer system. At the base, we have our pin. Cool. We have some driver on top that uses that pin for some reason. You have another driver on top that's like maybe like part of it's another high-level driver, not exactly a system, but it's still another high-level driver that needs that particular other driver to work. And then on the top, you have your system controller, or like your big system controller that talks to all the things below it. If you were to use static polymorphism all the way up to the top of this, and let's say your system is meant to be then modular, so that you could swap out implementations for different things if you needed them. If for all 4 of these layers, let's say you needed not just one copy of your or not one version of your system, you need multiple and many of them. If for any one of those other variations, you change the implementation for the GPIO, you now have several new implementations pop up out of nowhere inside your code. And as you continue to add more and more of these separate implementations, you start to grow and grow and grow. If your compiler let's assume the compiler can't inline everything for you, you now have a lot of code bloat, a lot of the same algorithms, but just in separate places because they're separate instances of that. If you do a lot of inlining, as you might know, if you have a very large function and you try to inlining it, let's say you call it 5 times in a row, inlining it is going to be a lot larger in your code size, duplicating that same code over and over again versus simply having a single function call that you call back to. And this is something that I actually noticed in some of my own projects where I did a lot of CRTP back before we had concepts in order to make this thing happen. And as I started to see this monster start to grow, I'm like, this is becoming a problem. But this is supposed to be faster. It is faster. It is higher performance. But I'm still, my code size is going to get pretty big, and I want to add more features. And I hadn't hit the limit of my flash yet, but I was getting kind of worried about that. And that's when I started making the switch over to runtime polymorphism. And then I realized that things like people say like, oh, if you use virtual, you are forced to use RTTI. That's not a thing. You just turn off RTTI, you're good to go. It's not necessary. If you want to do dynamic cache, you need it, but otherwise you don't need that. I've heard people say that virtual forces exceptions. I don't know where that comes from. I've seen some articles on that, but yeah, like I've heard that too, and I was like, that's not a thing either. Also, just turn off your exceptions.
Yeah, the RTTI one, I definitely would have. I've never heard people say that requires exceptions. That's interesting. I mean, I'm not arguing with you. I'm just saying that's interesting.
Yeah. And then other people, so there's like kind of things that seem like myths that aren't, for the most part, true. Then there's like the things that are kind of true. Like, for example, it's slower. That is true. Okay. And there's the other part, which is that it is it adds more space, and it will add more space if on small projects. If everything gets in line with your other code, it'll get more, your static polymorphism will be smaller than if you had a vtable plus an actual function call plus your actual code that's calling it. But once you start to scale up, it starts to invert, and that's what I started to notice, and that's why I went over to runtime. But here's the crazy part. Let's say you want to have static polymorphism performance. You can still do this with runtime polymorphism. You can still use virtual for this. Just simply, sorry, I'm getting a phone call. Can't laugh. I had this thing on Do Not Disturb, but I still saw it come up. Just take that object as its type. Let's say I have a GPI implementation for the LPC chip here. Pass that into a function that takes it as a template and use it that way. Your compiler will devirtualize it almost always once you bump it up to optimization level 1 or above. So, and once it devirtualizes, it realizes, I have all information about the function's implementation. I'm just going to inline it for you. So, to me personally, if I use runtime polymorphism, I get both the ability. If I use virtual, I get both the runtime polymorphic version, and if I ever want to go over to static to get the performance up, I can just simply do that by making the thing a template or make a concept for it, pass it in that way.
I've got 2 follow-up questions.
Please do.
I don't want to forget. Shoot, I already forgot one of them.
Oh no.
No. Okay, so Do you use or teach finals to give the compiler more hints about when it can devirtualize something, when it's appropriate to use final? Because it's hard to determine when it's appropriate as well.
Yeah, I think for the longest time, so I would say now I'm still kind of figuring out when is the best place to put final. Just because like I've had some students like, hey, I want to extend this particular class to do X, Y, and Z. And I'm like, do you really need to? And I think they had like one particular point. I was like, actually, that makes sense. And okay, sure, go for it. But in the class, I would tell people, there's not really going to be any deeper level of driver for this. If they needed to do anything more, they should probably edit the driver itself and that kind of thing. So I would actually tell them, after you've inherited from the GPIO interface or the output pin interface, mark it final.
Okay.
But that's still a thing that I still battle with myself.
And now I have two different questions again. Okay, so although one thing I just don't want to leave on the table here, you mentioned RTTI and exceptions, but I think most people really associate dynamic polymorphism, virtual functions, with dynamic memory allocation. Is that necessarily
Oh, yes, that's
true?
another one. Yeah. So the answer to that's going to be no, because so as someone who literally has all my builds check to see if malloc is ever even a symbol, it doesn't come up. It's not there. It's and I have no problem with malloc. I have no problem with new. I think dynamic memory allocation is actually fine and embedded. I just think that like my drivers shouldn't be the ones to do it.
Sure.
If I can keep it static, it should be static, or like dynamic allocating.
Right.
But yeah, no, there is. I'm actually trying to remember. I saw that an article years ago that someone said that, and I forgot about that fact too, and I don't remember why people thought that.
Well, I think partially comes down to like generally, often, if you're using dynamic polymorphism, it's because you want to shove a bunch of these things into like a vector. And then the only way to do that is to have a bunch of like unique pointers or shared pointers in the vector or whatever that then point to the generic interface.
Yep. Yeah.
So you create these things locally on the stack, and then you just use polymorphism just to simplify the calling interface.
Exactly.
Okay.
So you mentioned not using exceptions, not using RTTI. How do you deal with error handling when writing these drivers and everything?
Yeah, I actually asked the guy who works on this project if I could, name drop him in the in this talk. And he's like, "Yeah, absolutely, dude, go for it. It's a free country." So I use Boost Leaf, and okay, not gonna lie, I was when it comes to error handling, my main thing was always exceptions. I actually love exceptions. I know a lot of people hate it. I think exceptions are great just because of the fact that I don't have to muck around with my return types. Return types or my input types for my parameters. I can throw any type I like. I can, and I can just include in the documentation saying, hey, this thing can throw this in this situation. I can inform people about what this thing can throw. I know there's a lot of reasons why people think, exceptions are terrible. But I usually prefer it. And actually, my old development environment, my old framework that I was building actually used exceptions. And I was so forward for exceptions that I would recompile the ARM GCC compiler for all the platforms, my Windows, Mac, and Linux, so that you could actually, turn it on and then actually use it there. Side note for anyone who doesn't know this, if you try to use exceptions in ARM GCC, by default, the compiler is compiled with exceptions turned off. So it will just terminate the moment you try to throw something. It should actually, the moment you try to throw something, it will terminate. Now, I used other things, like I did the global variables, I did the return integer or return
Like
enumeration. Yeah, and I think we all know like why that's just not a helpful way to get information out. I used error code. Error code has one big fatal flaw that makes it kind of difficult for anyone who's embedded to use it. If they have
You're
this
talking
rule
about
of,
the one in the standard library, right?
yeah, it has a virtual return message. Its return type, message is virtual, which is fine. Its return type is string. So I can't change the allocator for that. I don't have control over that. I am stuck with the default new delete allocator.
Really?
Yeah. Huh. If it was like templated and I could like control the allocator that way, that could work. But it's not. I'm sorry, you actually can't have a virtual template, so it would never work that way. Sorry. But so because it returns a string, I'm stuck with needing to have memory allocation there. So that's one problem with error code. Let's say I ignore that. Let's say I'm fine with that. There's another problem with kind of std expected, and I'm not saying I think std expected is actually still useful in a lot of cases. Just when it comes to interface design, I had a lot of problems. Specifically, what do I make the error type? Like, for example, I could have an error type, a whole bunch of custom error types for GPIO, and I learned about this problem I was going to have, which is called the composition problem, or the implementation problem, where everything in my interface can be rebuilt using I2C. That one communication protocol pretty much does everything. So if you want to create a GPIO, normally GPIOs don't fail. They, like, when you try to set them high or low, it's not really a fallible thing. But when you introduce I2C, that could fail. So now I need to be able to transport, if my implementation uses I2C, to communicate to some chip external to my board and wants to twiddle some bits that way, that could fail, and then I need to report that. How do I report that through an interface that does not allow reporting of it at the moment? If I assume that GPIO setting high and low doesn't return an error, so I need to return std expected, probably void for setting it, and then an error type on top of that. Now, what do I include in those error types for, like, the enumeration? Like, if there's an error code type for whatever enumeration I have, I can have all the list of I2C errors and all the list of PWM errors and whatever else that I can put in there. But the issue comes, well, one of them that happened to me was someone working on the code base was like, hey, I have a problem here, and your code's in a different repo, so I need to add a new enumeration. So I need to make a PR to your repo to add another field to your enumeration, because I have an error that's outside the range of what you've already supplied. You didn't think of every single possible error, and you can't really use the POSIX errors because a lot of them actually do kind of work, but some of them don't really fit embedded because they're all about, like, operating system stuff. So with all of that, I ended up realizing that, like, you have the central place for where all this information for what type of error can occur. You have to keep updating and updating and updating. And what I really want is people to just be able to throw whatever errors they like. Like, if they come up with a new error category, I want them to kind of just be able to express it versus needing to talk to me or to whoever's working on the framework to say, hey, I need to make this change. And if you have control over the code, you just notice that particular enumeration is expanding. You may even see that, oh, these two actually are the same thing, but we have now two separate names for effectively the same type of error condition. And we have to just live with that. And people are going to ask, well, which one do I choose? It's like, whichever one you like, whichever one's your fancy, whichever one's shorter. So there are other things with std expected that, like, I had other issues with, like some copulation stuff that might have just been on me and me doing some funky stuff. So going back to Boost Leaf gives you that capability. In C++11, without exceptions, you can throw any type you like. Not only throw, you return new error. Your return type...
Does it ever do a dynamic allocation if it's like a big object or something?
No, it never does dynamic allocation. It's always stack-based, unless you choose to dynamic allocate it.
Okay. Sorry.
Oh, no worries. Yeah, no. That's a great question because, well, I'll get into that in a bit, like how it's done, and I think it's super clever. But yeah, your return type needs to modify. You need to modify your return type, so we still haven't stopped touching the return type. It's now boost, leaf, result, chevrons. You put whatever type is. In this case, void or bool, whatever you're interested in. And what that type is just simply that type that you specified and a bool on top. The bool just tells you if there's an error that occurred. It does not have any information about the error in particular. Here's how you capture errors. You have this thing called a do something handle or do all handle. You give it a lambda. The lambda is like your try scope. Then you have, after that lambda, you have all of your catch scopes, which are just more lambdas. The variable you put as the parameter for that scope, once you put in a new handler, Boost Leaf will figure out what the parameters are, then allocate those parameters on your stack, point the leaf system to point to those variables. So if any calling function deeper in your code ever throws an error, it just writes directly to your stack above. So when you actually make your way back up to the top of your stack, that one's already been filled out with the error information. So he has this thing called like O of 1 transport of errors, because the moment you throw it is the moment it gets written to. And all you do is like make your way back up before you can actually see what it is. Now people can throw arbitrary things. You can now handle arbitrary things. There is one caveat, which is that if you forget to catch something, it doesn't terminate or doesn't abort or something like that. That's one other issue. But that's kind of how Boost Leaf works. And because it's not allocating, because it's very dynamic, you can choose however you want to do your errors. and there's a lot of other cool features with it. I found it to be a really one of the best ways to kind of couple all the embedded thing, all the worries people have for embedded when it comes to error handling, and have it work for the embedded space and have it be as flexible as exceptions.
It's like the author hand-rolled return value optimization ABI calling conventions, basically, because it's a hidden parameter that is the potential exception, and it makes it then kind of like Herbceptions. Yeah.
That was his inspiration, was Herbceptions. He's like, we can do it this way, and it's like, I'll make it work right now. I will say though, there's one caveat to this, which is that it does require thread local storage. Because there's like basically a global variable for the lowest handler needs to have a pointer somewhat globally so that any of the lower code can basically write stuff back. So each thread needs to have their own implementation of each one of the different types of errors that could come up. If that makes sense. I don't know if I said that a little fast.
Oh, no, it did. I'm sorry. I'm completely, I just realized that technique probably would have solved some of the problems I had in ChaiScript if I were still maintaining it. Well, anyhow.
I was going to say, I think we're starting to run low on time.
We're running low on time, yeah.
I know you are working on a framework for helping embedded developers. I thought I would give you a chance to kind of talk a little bit about that before we let you go.
If you're ready to release it publicly or not, or...
It is not ready to be released publicly, but like the thing is, so I'll talk about it. It's called libembedded.how. The idea is actually to kind of shortcut through some stuff. It's a implementation of Rust's embedded HAL. They have this library, this crate that's supposed to be like an interface for all their embedded stuff. And I remember I kind of broke down that day I saw it because I was like, this is what I'm building. And they already have so many people already working on this. I'm like, why doesn't C++ have this? I'm so mad that C++ doesn't have this. And I even considered at some point, I was reading the Rust book and I was looking into it. I was like, was I wrong this entire time? Then at some point I spent some time soul searching. And I was like, you know what? If anything, C++ should at least have this available. I haven't seen anyone else do it because most times they'll tune it for a very specific architecture or very specific, we just work just for ARM or we just work just for RISC-V and we're not going to try to expand it to work with anyone else. Well, I forgot, I'm trying to remember the phrase, but basically, I want to support everyone. I don't care. Like, I'm not just for ARM. I'm not just for RISC-V. I'm not just for Arduino or AVR. I want it to work for anything, including SBCs as well. I don't think there's any reason why you couldn't have your code work on in a Raspberry Pi. Or I did an example where I was able to blink my caps lock on my laptop. Like, there's no reason why you couldn't have a GPIO be represented by the caps lock LED. And the idea here is to make a general set of interfaces that can be used basically anywhere, so people can write their algorithms however they want to, and go, oh, someone can ask, does your chip have drivers that are libembedded.how compatible? Because if they are, I can just do Conan install your thing, and then get all your libraries in, and they start using them immediately. And that's kind of the hope, is that I want to make development for embedded as simple as what I used to do when I worked on Node.js a lot, or Python, pip install, npm install, get the driver in, start using it immediately. Don't have to think about anything further than that. Just start going.
Very cool. When do you think it will be ready to release publicly?
I'm honestly, so I take a lot of time to make sure that I got things right, and even the last year has been me. The counter class has been one of those things that I've been fidgeting with for the longest time. Just a hardware counter, and I would say I'm hoping to get the first version in Conan maybe in the next 6 months, the next half a year. Just so I can get some of the students at San Jose State, the robotics team helps me out with this, and they work with stuff there. And side note to anyone who's viewing this, I think one of the most useful resources is having students look at your code, because I can have people who are experts look at my code and they'll be able to understand it, but when I give it to students, they're like, I don't get what you're doing here. I'm like, that means that I need to make my code a little bit more expressive. I need to make it a little easier for people to ingest. So yeah, they'll probably be using it for their little robotics projects here and there, and they'll be able to tell me, yeah, I tried doing this thing and it didn't work correctly, or I was able to get myself into this hole and this is a problem. I'm like, got it. I never thought that no one would do that, but you did it, and let me fix that.
Good point. Now, I just want to say, for if we have any hardware manufacturers or anyone listening right now, I think that every laptop and keyboard should add a Khalil light, so that if you don't have to actually twiddle the caps lock, but it would be some little GPI low light that just happens to exist there for people to program.
Okay. Well, Khalil, it was great having you on the show today. Thank you so much for talking to us about embedded development.
Thank you for having me on.
Awesome, thanks.